Now we're going to look at the coefficient of correlation, and that is from section 11.5. The correlation coefficient, let's first do the calculation and I'll tell you how it is useful. A perfectly straight, perfect line would have a correlation coefficient of 1 if it has a positive slope and -1 if it has a negative slope. So R has to be between 1 and -1. If R equals 1, we've got a perfectly positive slope. If R equals -1, it is it's a line with a perfectly negative slope. An R of 0 means there's absolutely no correlation in a linear way with this data. So the goal is to get a correlation coefficient that's close to 1 or as close to 1 as possible. The closer to 1, the more strong of a linear relationship you have. Okay, so we have these numbers already. 1.175 divided by the square root, 0.00211 times 1643.5. What I got was 0.63, around there. 0.63 is actually a pretty decent correlation coefficient. It's positive, which tells me that we have a positive value here. We have a positive slope, which is what we did find. We can use this to determine R squared equals 39.69, or roughly 40%. Okay, this is percent. What this is saying is 40% of the time the number of games won can be related to the average team batting average. 40% of the time, the number of games won can be related to the average team batting average, which conversely means 60% it cannot. Now, in the world of numbers, it sounds kind of dreary that only 40% of the time this relationship actually makes sense. But a correlation coefficient of 0.63 is pretty good. We found that the slope isn't 0, so it's contributing to y, and we can use this model, the original least squares model, to do some predicting. And we'll do that in the next example.